Okay, so thank you very much for being here. It's the last talk, and so naturally I'm going to keep this very lightweight, but I still wanted to make a very engaging and hopefully entertaining, inspiring talk. So I read some blogs, and apparently one of the ways to get your talk very engaging is to start with a very controversial statement about the topic that you are going to discuss. So I thought really hard about debugging and what would be the most controversial statement that I could come up with that I can still defend. And so I came up with this one. Debugging is fun and exciting. And so if I look at the room, I'm very happy that this reaction is there, but it's also a little bit sad because it seems to be that most people experience debugging as not fun and not exciting. And so depending on which research paper that you're reading, you will encounter numbers from 40 till 60% of the development time is spent on debugging. And so basically, if you are saying like, well, this debugging is not fun and not exciting, you're basically saying that programming is not fun and not exciting. And being on a PL conference, we should at least strive that debugging should be fun and exciting, right? And so just to, is there something wrong?
I don't know. Continue.
Yeah, and just to make sure that we're all on the same page, I will just describe what I think is debugging and what the debugging process actually consists of. So the debugging process consists of 3 different steps. Namely, you first need to detect that your program has a bug, yeah? And then you need to go into the code to locate where in the code the bug actually has manifested itself. And then finally, you need to eliminate your bug. And that's hopefully the really fun part, that you are converting your program into a working program. And apparently, this is very difficult. And so the reason why it's difficult is because there can be a very large distance between locating your bug and where you, actually I have another adapter, maybe I can just quickly change it, or, well, there is an excellent paper about my hairiest bug war stories that I would everybody recommend to read. So in this case, there is basically a program that he describes that is only working on Wednesdays. So what happened? Basically, the documentation said that you only needed 8 bytes for your day, to store your day, and Wednesday has 9 bytes, right? And then you get a buffer overflow, but actually it was working. Why? Well, the 9th byte was actually being used for user input, and totally by accident, it was reading yes. And so only on Wednesday it was correct. So you can imagine that it's horrible to debug this kind of bug. No? And so if we agree on the debugging process, then actually for this presentation I'm going to assume that the debugger is any tool that can help you with the debugging process. Okay, and so there are many tools developed. Going from delta debugging, back-in-time debugging, machine learning techniques, and so on, that help you in this process, right? But if you go to a developer in the wild, he's not going to come up with these kind of examples. What he's basically going to tell you is some kind of vision that comes from the 60s, right? There is like this excellent presentation, The Mother of All Demos, by Douglas Engelbart, that describes a system where you can already step into, step out, and so on, all the things that you are that you know from Visual Studio Code, for example, right? But it's actually even a little bit worse, the situation, if you just ask the average developer, because all these debugging techniques that I've shown here, together with like the older debugging techniques that you have, they have one fierce competitor that can actually compete with all these kind of debugging tools. Print. So print versus all other debuggers, which is actually you might know this anecdotically. but there is actually a research paper that actually posed this question to more than 100 developers. And so they also investigated other things, but one of the statements that they were actually asking to these developers was the best invention in debugging is printf. So I'm just going to quickly summarize the results of asking this or posing this statement to the developers in 3 categories: the good, the bad, and the ugly. And so printf, the good, is that there is some evidence for disagreement. And that basically means that there are developers out there that think that printf is not the best invention for debugging. And then the bad is that there is a strong partial agreement, which is kind of that you can that is being explained by the ugly. So many developers think that from the moment that you have a difficult to debug program, for example, with concurrency and so on, that all these debuggers, that they interfere with the actual base program. And so if you are using these debuggers from the 60s, that's true, but like all these different techniques that we have been developing actually really make sure that this is not the case. Yeah? And then, which I also find very ugly, is that some developers, they are like, well, of course, I'm not using printf for debugging. I use structured printf, which basically boils down to logging. And so from a software engineering point of view, that's true. It's better to log than just put printf through your whole program. But from a debugging point of view, this is not debugging, right? There are much better tools for that. And so this begs the question, why is it that these developers think in this way? And so if we go and look at the IDE usage today, we see that Visual Studio is clearly winning. And so if we go back to when the study was done in 2018, then we can find on GitHub that just the action of starting the debugger was very problematic. So there was a bug report in 2017 that basically said, like, I don't know how to, I cannot start the debugger. And then luckily that was addressed almost a year later. In 2018, it became much easier to start the debugger. So it already starts with how do you start a debugger? And then when you have the debugger, it seems like they are not very sophisticated in these industrial tools, because most debuggers do not know about while. Yeah? And so while has been invented for some time now, and if you are a developer and you want to debug your program and you encounter a while loop, one of the actions that you would find very normal is that you can jump out of your while, for example. And so I also found this to be one of the questions on Stack Overflow, and the solution is, there is a solution for that. So basically what you need to do is you need to put a breakpoint after your while loop, and then while you're in your while loop, you need to disable the breakpoint, and then you press play, and then you jump over your while, which is a way to do that, but you would imagine that like modern debuggers sculpt for your language would be able to offer you this kind of functionality. Okay, so that's based on the language, and then I'm going to still show you one small example. This is the Inside debugger for writing CPU programs. And so I'm going to zoom in on one particular point where there is a threads view. And so you see this list of threads. Well, in the Inside debugger, you get approximately 16,000 of these, and you can manually click on it. And so basically what this boils down to is that you're transforming debugging literally into finding a needle in a haystack, because you need to go through all these threads in order to know where the bug actually is. Okay. And I kind of want to give a positive message, and I only have been saying actually things like, well, the industrial debuggers, they are not making use of all these kind of things, but that also brings like a huge opportunity, because with the PL community, we have been developing all these different kind of techniques in order to help you with debugging. And so I was lucky enough to be working with some people on several of these techniques. And so I will kind of highlight some of these next generation debuggers on 3 different topics: non-determinism, resource constraints, and temporal and event-driven programs. Okay, so I'm going to start with multiverse debugging. And basically, this is a technique that we did with people from Gent University and VUB. And so what this basically gives you is a way to debug non-deterministic programs. And so instead of just showing one execution trace, a normal debugger shows one execution trace, we decided, well, wouldn't it be cool if we make a debugger that shows all the execution traces? And so this is a small example in the context of ambient programming. So this is a small actor language that we modeled. And so you basically have a model where actors have objects, and so these objects, they can have references to other actors, and then you can send messages between them and you can get a result as a future. Yeah? I'm going to highlight one small example, which is of course constructed so that it's easy enough to show during the presentation. So we have three actors, a math actor which has 2 methods, double and get result. And then we have 2 clients. The first client sends a message double with the argument 12, and then gets the result from the math actor and prints it. Right? And then we have an annoying client 2 that is also sending, for no particular reason, double 33. Yeah? If you have this kind of system, you can get different kind of interleavings. Namely, client 1 can send double 12 first, and then the client 2 can also send double 33. Yeah? And then it's going to go wrong because basically what client 1 is going to get as result is the number 66, because the interleaving of the client 2 was in between. The other 2, they are correct because client 1 sends double 12 and then gets the result, and then the last is client 2 first sends double 33, then client 1 sends double 12, and then you get the result. And so we consider these also to be what you actually want. And so with multiverse debugging, what you actually can do is you can execute this program and you see all the different states. And so the red states are the end states, that the end of your program, and you also immediately see that there are three different interleavings. So we actually did this in a rather formal way, and I'm not going to go into details about this here, but basically what's interesting about doing this in a formal way is that we have like a recipe in order to debug non-deterministic programming language semantics. So first you define your semantics, and then what the paper describes is that you can actually embed your language semantics into the debugger. And so if you do this according to the way that we have described in the paper, you get a debugger that is not interfering with the base semantics. Okay, and then some of you might be here like, well, you just showed like this example from NVIDIA Insight that shows 16,000 threads. Basically, you're doing the same. You're just now showing a bunch of nodes, and they can explode, right? Yeah. So what we also did is we defined a query language on top of our debugger that allows you to prune this trace. That's the first thing. And then the second thing is that this is actually an interactive debugger. So instead of showing the full execution graph for bigger programs, it actually allows you to go into certain directions. And then, of course, it's up to the debugger, the programmer that is debugging, to explore certain parts of this space. But what's really important is that we give the developer the tools to see these states, because a normal debugger will just show you one execution path, and you will have to rerun your program in order to find your bug. Right? I think there are lots of opportunities, and I'm also really happy that this idea of multiverse debugging is actually being picked up by other programmers, researchers, I mean. And this morning, actually, there was a paper that actually defined different kind of breakpoints for multiverse debugging. Okay. But there is still a lot of things to do. For example, state explosion, it's not really solved, right? There are techniques to make it better, but we still have lots of problems. Okay, let me go into the next kind of debugger for resource-constrained devices. So for resource-constrained devices, the story is exactly the same, right? We found that many embedded developers just use printf, and that one other technique that in embedded systems which is used a lot is that you just simulate the device. But from literature we know that the programmers like to debug on the hardware, because there are just some things that you can only find out if you're debugging your embedded device live. Yeah. And so there are, of course, techniques in order to debug embedded devices. It's just a kind of remote debugger. And so how does this normally works? Well, you have some kind of debug monitor running on the device that is talking to your developer's machine, and then it basically instructs like how the virtual machine that is running on the device needs to step through. So the disadvantages of remote debugging is that the debugger is actually running on the microcontroller, and you need communication with this device for each of the debug instructions. So you can imagine that it becomes quite slow. So we got some inspiration again from people from the VUB, which is called out-of-place debugging, which was a technique that was invented for big data applications. Yeah. And so we kind of took that idea, and the basic idea is that instead of running everything remotely, that you're actually going to run it hybridly. And so you're actually going to execute part of your program on the developer's machine instead of on the microcontroller, and then you're going to communicate with hardware only in certain spots. So we call this location independent and spots in your code and non-transferable resources. So where does these non-transferable resources come from? Well, your microcontroller is connected to sensors, and these ones you cannot just move them to. You really need to talk to the microcontroller. And so there are actually two kinds of ways in how you can do that. One is pool-based, which means that the developer's machine is going to ask, like, what is this certain sensor value, and the other one is push-based. And that actually means that the microcontroller is going to send values to the developer's machine. Yeah. And so we work this out, and then we have an event queue which actually is going to run part of the program on the developer's machine and is going to execute only those things that it cannot transfer to the developer's machine. So what did this give us? Well, actually, what we did is we made a Visual Studio plugin, which allows you to debug programs written in WebAssembly on our virtual machine. And as an example of the kind of things that then you can actually get, we implemented back-in-time debugging. Yeah. And then one small thing that I also would like to highlight: whenever there is an event coming in, instead of executing all these events at the moment that they come in, while you're debugging, you can actually just queue them. And that's also very helpful, because then you can choose a good interleaving in order to reproduce your bug. You know? Again, here there are many opportunities we haven't explored, like if you have groups of IoT devices. We also don't know how to do this debugging on IoT devices which are remote in a secure way. And then, of course, we could also think about making this debugging infrastructure more performant. Okay, so after looking at non-determinism with programming language semantics, looking at resource constraints, then I thought like, well, let's make one ultimate challenge, and let's make a debugger for a multi-threaded language with a message passing interface, with event-based graphic applications used by millions of programmers, and then with programmers who actually do not have a computer science background. Can anybody guess which language this is? Close, but it's actually Scratch. The Scratch programming language, it's actually a very weird kind of language. And so in order to debug this, we needed to think about an interface that makes it easy for children to use the debugger. And so what we came up with is like we introduced, so for people who don't know Scratch, it's a block-based programming language. And so we introduced some blocks in order to allow children to debug with blocks. And then what I call the YouTube interface. Whenever you are running your program, you can actually just make a recording and then go back in time. So I'm just going to show a very... no, I'm not going to do that. Sorry. So if you want a demo of this system, you can talk to me later. So we actually evaluated this with a bunch of children. We gave them some task in order to debug, and then we actually got some quite good result because most of the children really liked the debugger. And just to give an anecdotal example, there was, after the workshop, there was a kid that had been debugging his application for almost a week. And then we attached our debugger and we went through the program, and I don't show Maxime completely out of privacy reasons, but I can tell you that while we were debugging it and we found the error, that this kid was extremely excited to have finally found his error. Okay, so for opportunities here, well, we only explored like one kind of advanced debugging technique, and there are other research groups busy. There is with Scratch. There is on the ICSI conference, for example, Nuzzlebug, which is where you can ask questions about your Scratch program. For example, like if you move a ball, you can actually ask like, why did a ball hit something? So if you're interested in this kind of research, you should really check out also that work. Okay, so let me round up. I really think that debugging should be fun and exciting. And so I have like 3 kind of suggestions of questions where I think as a community we can think about. And so one is programming language design. Instead of looking at debugging as an afterthought, wouldn't it be great to shape your language so that the language actually makes it that debugging becomes easier? I don't know how to do that, but it would be extremely beneficial. And then how to formally define debuggers and their proofs for correctness, because if you read type systems papers and so on, we now know how to prove type systems correct. There is like progress and preservation, but for debuggers, there is of course formal research about that, but there is not such a widely known technique to prove the correctness. And then finally, many of you are in an educational role, and so I think it's really it would be beneficial to think about how to teach debugging, because most curriculums, they actually do not teach you how to debug. And so if you are interested in knowing more about this, you can check this book by Zeller, and it's an excellent book that explains you how to teach debugging. So to really round up, I'm going to give I'm going to make some advertisements. So this year we organized the depth workshop together with Elisa, and so we got actually quite some people. There is somebody from Japan, which is remotely there, And so we are going to organize DEBT again next year together with eCoop. And so I want to just stop the presentation or finalize the presentation with a call for action. So let's make debugging fun and exciting again.
Who got a question for Christophe?
I guess I'll go. So I actually had worked with the Chakra JavaScript engine team in about 2015 when they were doing their time travel debugger. And one of the things I found really interesting, JavaScript. So people love printf debug console.log, same thing, right? One of the things that was really interesting to me when talking to people about why they use that as their debugger, and that was the first thing they reached for. The two things came up. One was, this is a live incident. I'm trying to fix the bug now. I don't have time to learn to set up and use the debugger. So I'm going to use what I know to solve the problem quickly today, even if it's not optimal in the long run. And so we ended up doing, and I've spoken with some other people, that do time travel debugging work. And this adoption really has had most success when you integrate it at other points in the development lifecycle, like flaky unit tests, CI pipelines, other things. I was wondering if you sort of had experiences in that area, or what your thought on that was. Like, not just thinking about it as debugging, but as a tool generally.
Well, I partially already said that I think it's really important to educate people on debugging. And so I think lots of times outside of debugging, yeah.
So basically, I got the version of, I don't want to learn a new tool. It's not exciting. I need to fix it right now. So you had to kind of sneak it in somewhere so they'd start using it and say, oh, this is really cool. I learned it. Now it was in their toolbox. But if you went and said, let's learn about debugging, people were like, nah, pass. I don't know why, but that's a very strong signal we got there.
Yeah, but even on the debugging workshop that we organized, one of the topics that came from the discussion was, well, I don't like debugging. So you would imagine that people submit papers about debugging, have some kind of affection for it, but even there we actually saw that some people were like, let's make automated debugging tools and so on. And so I think it's our job to show that if you use the debugging tool, you get some benefit from it. And I fear that many of the tools that are being generated in general, for example, Visual Studio Code, they are not making a specific debugger for your programming language that is going to be the most valuable for you, right? And it's normal because they are an IDE, and so what do they do? They develop an interface for all different kind of languages, and so you end up with like the greatest common denominator, and you get a step into and step out, which we kind of know from the 60s. So I think you should show value to the user, and then adoption will come, hopefully.
And get the users very early, as you do.
Yeah.
I was the second, but you already answered my question, actually. But maybe you have an additional insight into it. I was wondering, I mean, there is obviously, this was very interesting, thank you, and there are things happening in the academic community in terms of like extending debuggers, writing debuggers that help you debug different things. My question was, why doesn't it end up being adopted more in the industry? Like, why don't people, like, to your answer, which is that, there are these IDEs that cater to multiple different languages and have to have uniform interface. Surely there are languages that are popular enough that there could be a specific IDE for this language that could incorporate some of the debugging techniques that are, more interesting. And I don't think there are. And again, why do you think that is?
So why do I think?
Why do you think that there are no industrial applications for more interesting debugging techniques that are obviously being developed and currently being developed?
Well, I kind of answered the question. Yeah. But yeah, I think from research we should show value, and if we do that, I think industry will follow.
So maybe this is the point where I step in as an industry representative, and my colleague here and I have been talking about this a bit, and we use debuggers very extensively. In particular, RR, the time-traveling debugger, is the tool I use daily that makes me feel most like a wizard. And Matt is a very heavy user of Pernosco, which is the sort of extended web-based interface to that. And so at Mozilla, we actually make pretty good use of time-traveling debuggers as a means of capturing and then exploring intermittent bugs. And one thing that we have done, which may be a partial answer to how do we integrate this into the rest of the process, is that we have the ability in our CI system to capture a Pernosco trace of a task that is failing in an attempt to then grab something that we can then debug. And so we have tried to take these tools and like actually build them into useful things that like fit into people's workflow. And I mean, I think time traveling debuggers are incredible, so do more of that.
I would go one step further, and I would actually argue that in your undergrad courses, if you were teaching C and C++, and you do not teach time travel debugging, or Pernosco, which is omniscient debugging, I think you're committing malpractice, because it is an actual, like, it is incredible, the difference in power. And if anybody wants a demo of Pernosco, I'm totally willing to show, because, like, I'm literally quoted on their front page as one of their customers, but, like, this is the biggest productivity improvement that I have at my Access, and I want to see more of it. You know, I get incredibly annoyed that Microsoft and Apple have not like built something of this level of power and made it like totally available everywhere. Like, okay, Pernosco's UI is terrible. It's designed by computer scientists. Like, sorry, we're all bad at it. But like, it is. Like debugging tools have gotten a lot stronger, and teaching debugging as here's next in printf is bad. Stop doing that.
Any more questions, comments?
Okay, just a comment why I'm using printf and why I will keep using it is...
No. We should see all sides of the story, right?
I'm building compilers, and when at the third round of bootstrapping my compiler I have an error, then the debugger is just of no use. Okay, when at the first time of bootstrapping your own compiler, your compiler crashes, what can you do with the debugger? The error was 3 times sooner, and then you have no execution at hand, so you cannot debug with a debugger. It's too late. It's way too late.
Yeah.
Hi, interesting talk. Thank you. So I think it's all the debuggers we can use today are basically tools for visualizing what's going on the machine. That are not really too directly to help debugging, because the work the debugger does is just visualizing what's going on. It doesn't help, right? It doesn't give any hints or directions or no guides. So do you have any ideas, possibly, whether we can get some much really debugging tool, like, which helps, what's next you do?
So I have not personally been involved in these other kind of debuggers, but basically what I think is that we should basically use static analysis tools in order to guide the debugging process. And so there are, from that perspective, we have developed many tools in order to get more automated debugging. Right. So, like, if for example, you could use symbolic execution to guide where you have to go. You can generate coverage tests for your application and so on. And I consider all these kind of tools as debugging tools. So I think there is plenty of this kind of research.
So you showed us that you're interested in resource constraint debugging. Do you also have some ideas on the resource abundant debugging? How do you debug 1 trillion actors?
I should think about it, but it's a nice remark. We can talk about it later. I don't have anything from the top of my head.
Hello, thanks for your talk. Do you know algorithmic debugging? And I think the way like interact with the debugger is better than just a time travel debug, next step or last step. So is there a way to combine this? It uses the time travel technique and ask users some questions. Is this right? And the debugger will tell the developers we should go next or go back. Or do you know some interesting work after the algorithmic debugging? I know little about this, so.
So actually, the debugger that I showed you, that I showed the reference from for Scratch, is kind of combining these things. So it is actually reasoning about temporal aspects of the Scratch programming language, and so you can basically ask questions like, this ball is colliding with some other sprite. Why did that happen? And so instead of actually having to go into a back-in-time debugging, it actually is going to tell you in the code, because at this point in time, this code is going to be executed. This is why they are going to collide in the future. So it actually already incorporates these temporal aspects. Yeah.
All right, let's thank Christophe one more time.